Hi, in today's video I would like to introduce a very nice problem of Hungarian Mathematical Olympiad edition 1911, question number 1. Here is the following question. Prove 3 to the n plus 1 is not divisible by 2 to the n for any integer n strictly superior than 1. In the other word, 2 to the n not divide 3 to the n plus 1, okay? Before I proceed with the solution of this problem, I'm going to remind you about a very important and useful theorem. Is called lifting the exponent. Okay, let's go through the definition. Let p be a prime and m a non-zero integer. Then we defined vp of m to be the exponent of p in the prime factorization of m. Okay, m is an integer such that vp of m equals k. This is the definition of this one. Okay, it's called this one. This is p as a prime, m is an integer, equals k as an exponent, equivalent p to the k divide m. So the prime, the exponent of this prime, so this condition p to the k must divide m, this integer inside of this one, and p to the k plus 1 not divide m. Okay, let's go through the theorem first. Let p be a prime and xy as integer numbers, n a positive integer. Okay, this is the condition. P must divide the difference of this number or the sum of this number. Okay, but GCD of p and x equals GCD of py equals 1. In the other word, p not divide x and p not divide y. If p is odd, we have these numbers is related to the exponent x to the n minus y to the n, equal the exponent of the difference of these numbers plus the exponent of this n. Okay, this is the exponent, not the number. This is the condition you have to hold. Always we have p divide this difference or the sum. Okay, so let's go through the second case. If p equal 2, if p is a prime but equal to 2 and even, we have to have this formula, v of 2 as a prime of this exponent of these two numbers as an exponent equals this one of the prime of the difference of these two numbers, the exponent of these two numbers, plus the exponent of this n plus the exponent of the sum of these two numbers minus number 1. Okay, always we have p divide this difference x minus 1. Notice if n is odd, we can put a substitution. I'm going to do the change of variable to get to this formula, to get to the plus instead of minus, to get to the sum of these numbers, not the difference. Okay, let's do that. By substitution I will get vp b of p of x to the n plus y to the n equals vp of x plus y plus vp of n. Okay, p must divide the sum of this one. Okay, if you don't have p not divide this sum, you cannot apply this formula. Okay, because we need these two terms to be factorized, because we need to make this one on the form of x to the n plus y to the n equals x plus y is multiplied by the something. Okay, we are looking for this one. This is our goal. I'm going to support this one with a concurrent example. Let's take this one as an example. The largest power, we want to find the largest power of number 3 dividing this number. I'm going to apply the same formula. First table, before I start with the solution, I'm going to check first table before I start with the solution. I'm going to find p. Which p I can take this one in order to have p not divide this one, not divide this one. Okay, so the number 3, you see the 3, so you have 3 not divide 5 and 3 not divide number 2. But the difference of these two numbers, but 3 divide 5 minus 2 equals 3. Okay, remember n is an even here. Okay, so when you have the n is an even with a minus sign, you can factor out this one. That means you can is okay to apply this one. But if you have plus here, this one plus this one, with the n is a even, you cannot factor this one out. You cannot apply either this formula, okay, because 3 not divide this one with a plus sign. So that's what happened here. LTE of this one, our goal for this one to find 3, this 3, it will be written on this form, is multiplied by something equals this number, 5 to the 18 minus 2 to the 18, okay. So I'm going to find this exponent. We are going to find the largest power of number 3. Now I'm allowed to apply this theorem, okay. So we'll have v the of prime 3 of 5 to the 18 minus 2 to the 18 equals v of 3, the difference of these numbers 5 minus 2 plus the v of 3 of this exponent 18, okay. So this one 5 minus 2 is number 3. So the exponent of this one is 1, okay. The exponent of this one 18, I can rewrite it as 18 equals 2 is multiplied by 3 to the 2, okay. So the exponent of this one equal number 2. So this one will have number 2 here, I have number 1 here, 1 plus 2 equals 3. Now the largest power of 3 is number 3, okay. Now let's move on to answer our question. In order to show 2 to the n not divide 3 to the n plus 1, I'm going to break this one into 2 cases, okay. So if n is even for all n superior or equal to 2, because we have the condition n strictly superior than 1, that means n is superior or equal to 2. This one I have 3 to the n plus 1 is a congruent to minus 1 to the n plus 1 is a congruent to 2 mod 4. Because if n is even, this minus 1 to the n becomes 1. 1 plus 1 is a congruent to 2 mod 4. This one is telling us 4, which is called 2 to the 2 not divide 3 to the n plus 1. Finally 2 to the n not divide 3 to the n plus 1, okay, because we said if any integer, even this one implies this one not divide this one, okay. So let's go to the next case. If n is an odd, that means n is superior or equal to 3. Now if n is an odd, 3 to the n plus 1 is a congruent to minus 1 to the n plus 1 equals 0 mod 4, okay. This one is telling us 4 equals 2 to the 2 divide 3 to the n plus 1, okay. Now this means this term, it can be on the form of the product. That means this term 3 to the n plus 1 is a multiple of this one. Now we are allowed to make this one on the form of the product. Now we are going to find the largest power of the factorization prime. We are going to apply the theorem that we saw. We have 3 to the n plus 1. Let's set p as a prime equal to 2. We know 2 not divide 3 and 2 not divide 1, okay. 2 as a prime not divide 3 and 2 not divide 1, but 2 divide the 3 plus 1 equals 4. Now we are allowed to apply this theorem. That means v2 of this exponent 3 to the n plus 1 like this equals v2, the sum of these two numbers 3 plus 1. As we said before, this is the exponent, okay, left-hand exponent, plus v2 of n. This one, it can be written as 2 to the 2, okay. This is 4 to the 2. This is the exponent that of this one, okay, exponent of n for the prime number, as we said before. If you have vp of n equals 1, okay, if p is superior or equal to 3. For example, if you have 19, v of 19 of the exponent is always equal to 1, because 19 to the 1, okay. Since we have a number 2 here as an exponent, this one will be 0, okay. So the exponent of this one equals 2. is inferior or equal to n. Okay, so the largest power equals this exponent equal to, as we said, for n is super equal to 3. Okay, exponent of this one equal to 1. Okay, the exponent of this one is less than this one. Okay, now we found this one is written on this form: 3 to the n plus 1 equals 2 to the 1 is multiplied by something. Okay, in order to have 2 to the n divided to the n plus 1, we must have 2 to the n divide 2, right? How become 2 to the n divide this one? Because this one has the exponent less than this one. Because we have n super equal to 3 is telling us 2 to the n not divide 3 to the n plus 1. Okay, so I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching, and we'll see you in next video. Bye.